Brad is doing the thing again, turning his
mode.
head.
Yeah. It's actually, this is kind of uncomfortable. Hello.
Hi.
Okay. Are you happy with your head design, Brad? Can we start?
Just keep going. You just keep going. Press ahead with the episode. I'm just gonna fix some stuff, but don't worry.
Well, welcome to another Honc Out. We are here again. The same setup as last week with Brad and Lau. And I think last week we already gave a cliffhanger that we want to talk about chocolate, right? Because we want to talk about, I don't know, how do you pronounce this? GEPA, I think, or GEPA? Not GEPA, I don't know. We want to talk about the GEPA algorithm. But
I think most have heard GEPA. Yeah.
GEPA. But funny enough, and I just have to mention it for the start of the thing, in Germany we have a whole brand called GEPA for fair trade chocolate, coffee, tea, and all sorts of things. But we are not talking about that chocolate today, unfortunately. But I can recommend.
Does it stand for something?
Sorry?
Does it is it why is it GEPA? Does it stand for something like gesund?
How can we? Okay, you know what? Before I do here the research, we can start with the intro of the GEPA we want to talk about, and I see if I can find out something and let you know by the end of the stream if I could find out for what it stands. But back to GEPA and tech.
Yes. Yeah.
All right.
I'm a little tired today, so there's going to be just like human lag.
It's always the connection. It's never the human.
Yeah, sorry, that was the connection for a second. Yeah. I mean, I can say why it's pronounced GEPA, and then we can go into what on earth we're talking about. But GEPA stands for genetic Pareto, and that's why it's pronounced GEPA, because genetic. And then Pareto is Pareto, tomato, is a way of optimizing, I suppose. I mean, like a lot of people think of the Pareto principle. In this case, the algorithm uses a Pareto frontier, which we can cover later. But that's why it's named what it is. But maybe we back up and we start talking about why this thing exists.
Yes. Yeah, I guess there's best way to talk about is the way we're going to talk about it in this context is it's in a family of optimizer algorithms. And specifically in this case, we're going to be talking about optimizing natural language text. So if you look at the GEPA repo, that's its primary focus. So for some context, one of the ways to use or sort of to make the most out of LLMs when building agents or MCP servers is optimizing the prompts. So I can share my screen and kind of walk through a few bits. Let's see.
And one way to think of prompt optimization is like automatic prompt engineering.
Yes,
I would say.
I had this amazing graph done in TLDraw.
Wow.
That basically, you have your classic loop, your prompt, you have your LLM response, you have a tool use, and then you as a human evaluate the result and you update the prompt. And the optimization is just taking this bit where instead of you evaluating the results, you run some evaluations, and then we can say LLM2 updates the prompt. So now you have a full loop where you have the initial prompt, the LLM response, the tool use, the evaluation, and then based on that, the prompt updating, and you kind of spin it until your budget is exhausted, essentially. That's usually how these things work. So there's a few tools, I think, both OpenAI and Claude famously had sort of prompt optimizers in their respective consoles. So you could sort of add your data sets and then optimize them. And then I think a framework that's, I would say, popularized it in some way the most has been DSPY, which is like a whole thing. We don't have time to get into that, but one of its key features has been sort of running an algorithm on your inputs and sort of tweaking them until you get the best output, which is what the optimizers do. Yeah, so essentially we sort of most of the time what these optimizers are optimizing are prompts. And then one of the key, I guess, realizations, or I mean, it's kind of a truth in some senses. Prompts have different shapes. You have your system prompt, you have your user prompt, and then you have tool descriptions and tool schemas that are also prompts, and they can also be optimized or evaluated. We talked about evaluating MCP servers last time, so if you can evaluate something, you can also optimize it. And so that's kind of like has been the idea of like, okay, what if we took that and went further and tried optimizing? And then GEPA has been probably felt like the best suited algorithm to play. Also kind of new hot thing, always fun to play with a new hot thing. And then also a great algorithm to experiment in environments where maybe you don't have like large data sets to evaluate on. So there's like a whole paper about it and a GitHub repository.
I did print out the paper.
You printed
You
out
did.
the paper?
And I figured I could do a dramatic reading if we have another hour and a half to spare on the stream. I can do all the voices.
Can I ask you a question? Well, I don't know. Maybe you find the answer on the paper, but maybe also Lau can just answer. So as I understand it correctly, GEPA is not only for the tool optimization, but can be also used for prompt optimization, like singly. We don't need to work with MCP servers and tools, but the idea is mainly you optimize your prompt and you don't need to have access to anything inside of the LLM because you can just go from the prompt.
Yeah, I mean, that's the original idea of GEPA, is that you optimize, or that's the original context that I think at least where the initial sort of applications of it were. And then we just sort of decided, it was like, what if we try that on tool descriptions? On the dramatic reading, I think we should definitely do it, but let's put up a separate stream for that. I'd be down to I don't know if you can do it in two parts. Like I don't. Yeah.
No, it's on my personal channel. I'm almost at double-digit subscribers now. I tend to read source code or readmes from the Linux kernel.
Really?
In a dramatic fashion. Oh, so you're not one of my 7 subscribers then?
No, I didn't know you have a separate thing going on. That's maybe we need to link it here in this channel as well. I'm sure people would like to see you dramatically reading things from the Linux kernel or now the research paper.
But what do we describe here?
I think so. Maybe a good way to talk about what the so I think let's quickly talk about how the algorithm works in a rough way, and then we can show like a little tool we built that sort of illustrates that in some sense. I know, Brett, that you've done some work on evolutionary algorithms before, so might be a good.
Yeah.
You want to.
What I'm going to show. I mean, we'll use this as an so like, it's a genetic algorithm, right? GEPA. And as this repo will show, 10 years ago, I played with genetic algorithms for one Saturday, I think. You can also see the change in my style as a programmer in this repo.
You loved emojis back then.
I loved emojis and commit messages. Just even the way I like wrote the README felt kind of 10 years ago. but the whole premise of this was use a genetic algorithm to find complementary colors, which I thought was kind of an interesting, small, digestible one afternoon type thing. I had to update the demo link because obviously it was broken because it was 10 years ago. But the whole premise, okay, so the algorithm here, and this is, you have to mind some of the terminology because it comes from genetics. Like it's just ripped from the idea of like mutations and populations and breeding and things like that, which can sound very strange, but it's just at least the textbook I think that I read or was reading, that's all the language they were using. So just to ground this in something concrete, like all this did is every time you touch the page, because it was mobile optimized 2015, every time you touch the page, it runs the algorithm and it tries to just from like a general set of 2 colors, it tries to find 2 that are most complementary after several iterations of the algorithm. A couple of interesting things was like the first time I built it, I flashed back to this. First time I built it, I realized that it was always going to white and black. And sometimes it would just like desaturate the colors completely. And I thought it was just kind of that's a good lesson in like overfitting, I guess. So the algorithm just goes, it gives you a population of 10 random palettes. It calculates, quote unquote, the fitness of each palette. And then it starts mixing palettes in pairs to create offspring, which are new palettes. And then it takes other palettes and it mutates one of them. And then it mutates another one kind of at randomly. And then it compares the top 10 amongst like this new population. So you made a bunch of new ones. And then it just repeats that until you reach something called a steady state. So in this, I actually did not do a steady state. I just have it terminate after 400 loops because I don't know. I don't remember why, if I'm honest. So this, you can just think of it as like you're going through a lot of generations where you're randomly mutating things and then you're mixing other things together. And then at the end of it, you reach some state where you're like, okay, this is the result. And in GEPA, that's called the Pareto frontier, which is basically like, well, yeah, we can get into it a bit. Maybe it's not worth explaining right now. But that's kind of, that's how we arrived at these somewhat complementary colors. So you can go to colorsandstuff.netlify.app and try it yourself.
How would it check that 2 colors are complementary? Like, is there?
Ooh, good question. I had to read the README. So this is how I corrected for the like too light, too dark, too saturated, and like making things go into just like basically black and white. So fitness is like how we measure whether we should like keep something across generations. So it's 0 if the color is too light or too dark. So I think I have some sort of clamp in the code. It's also 0 if the color is too unsaturated. And then otherwise this says it's the minimum squared angle between the 2 hues. So I think I'm using hue, saturation, and lightness for the color. And then if you think of like a color wheel where you can select a hue and wait, I have a color, not color sync, color. I know I have a digital color meter. No, I forgot a quick way to pull up colors, which is a pity. Color wheel. I don't want to spend too much time on this too.
Yeah.
But yeah, so if you think of like there's a blue over here and yellow over here, you look at the angle between those 2 hues, the minimum angle, and then that's like a measure of its complementariness.
Okay.
Probably not the best way, honestly. Now that I'm thinking about it, how did I? Oh, no. Because the angle could be like 180 degrees. So minimum squared angle would mean like at most it's 180 degrees. I would hope I did that. I don't know. Didn't look at the source code. So could be a bug there. File an issue on the repo.
There we go. The resurrecting 10-year-old projects. But I think that's like a good way to kind of talk through the whole, because the the algorithm in GEPA for example, tool descriptions works kind of in many ways the same way. So I pulled up a little graph that I wanted to show, and then I promise I'll show the tool right after this. But essentially, you have some sort of seed prompt that comes from, you connect to your, I don't know, MCP tool description, MCP server, and you have your tools, or you sort of throw in the initial prompt. And then in the initial iteration, it generates a few diverse set of candidates from that. So that's your first LLM call to sort of generates that. And then you run it through any evaluation set. So you need your, essentially for what you need for this is your initial prompt seed, and then you need a effectively evaluation data set that's is the equivalent of the fitness score of the color wheel that tells you, like, was this
how good is
a success? Yeah, how good was this?
Yeah.
And from that you take the best performing candidate, which scored the most on that, and you feed that information. So it's the candidate, it's the prompt itself, the tool sets, the evaluation set, and you feed it back into the LLM and say, like, okay, like these are the scores. This was the best one. Like, can you improve it further? And then you get, offspring candidates, and you continue this loop until effectively you've either reached the optimal score. So like all your evaluations pass, or 90% of evaluations pass, and or you exhausted the budget, because every LLM call costs money, and you want to cap that. And then you're left with an artifact that is your best possible prompt description.
But also meaning each candidate represents a prompt, right?
Yes.
Yeah.
So there's a couple of things that I think are especially interesting about GEPA. One is, so in the color thing, all I was doing was typically just generating a new random thing. But to create kind of new mutations or variants or whatever you want to call them, new candidates, you're using the power of an LLM to reflect on what went wrong and why, and then try to correct for that in some capacity. Which I think is that's the legerdemain, that's the cool and most useful part of the algorithm, I would say. It's leveraging the fact that these are language machines that understand there was some language here and here's some language there, and we know that this should have happened, and so it can try to draw connections about why, given the language that was used. And then the other thing, okay, I keep saying Pareto frontier, but I think the other trick of GEPA is that you don't just, so when we think about fitness, you don't just optimize for one thing. You can optimize for several things all at once. And the Pareto frontier refers to, if you're optimizing for 3 different things, it's when you've reached a spot where as soon as you try to improve this thing right here, you've, what's the opposite of improve? I can't remember the word. You've made this worse.
Yeah.
You've improved this, you've made this worse. And so once you reach a point where it's like, oh, I'm trying to make this better, but everything else gets worse, then you kind of know you're at your optimal solution. And what that means in practice. So ideally, you do want a prompt, like a description that always gets the tool response to happen. But you don't want it to be too long, would be one thing. And maybe you also you don't want it to, I don't know, use all the examples from your training set.
Yeah.
So if it gives 10 examples that are exactly the ones in your training set to try to hack the system, you kind of want to penalize it for that. So give it a bad score.
Yeah. I think that's, so then jumping into the tool, this was exactly the experiment of basically once you've connected your MCP server, selected the tool that you want to optimize for, like you take your initial, set your status description, then you can set a budget, and the key things were the sort of I think the like sophisticated term for what you just explained is multi-objective trade-offs. So you're optimizing not just for the score, in which in this case we're running the same evaluation that we explained last time, which was this tool called, but then also the shortness of description. For example, what is the least amount of words that we need to use for the LLM to invoke this tool most consistently, basically. And so like I think the most interesting part in this experiment was getting these evolution graphs. So you'd get your seed prompt, which was this, and then for every iteration you had ones that were either shorter or longer, like this one that was rejected because it was below minimum threshold of the accuracy, and then this one that was accepted but was longer. So one of the things that you realize that like the LLMs have gotten really good, and I probably should have ran more of these tests on either local models or just in generally more lower powered ones, was that even the 15 characters and the tool schema was often enough for the baseline to just pass the 93% score. And so then like in the iterations of the runs here, the subsequent calls were like the improvements were marginal or not that interesting. But if you have a more diverse evaluation set, or if you have a more complicated tool, for example, then I imagine a run like this would yield a lot more information.
I think in the other graph I saw some yellow and green boxes. Were they different? Like, is there a difference between those? Like, is green the optimum and yellow is
so
okay-ish?
greens are the Pareto frontier, because they're not just from the baseline, they were not just the most accurate ones, but they're also shorter in descriptions.
I think the evolution graph here was the sleeper hit of this tool.
Yeah.
What was? I must ask, what was the experience building it?
I think so. Evolution graph was very much a thing that came out of necessity for myself. As I was building this tool and testing this theory, I realized like I had no idea what was going on. I had the ranked list, and I had logs in my terminal, and I was seeing the results come in, and I was like, I was building it to understand the algorithm, and I have not had the understanding of the algorithm until I thought it was like, okay, well, in any cases when I'm visualizing this, I'm visualizing it like this. So why not essentially ask Claude to build like, okay, can you build me a graph? And it was actually very useful for debugging the algorithm, as I've noticed in a lot of cases, it would produce too many initial candidates, and it would just continue producing those as opposed to picking ones that were performing better than the previous one, or it would continuously pick the baseline as the one to continue from because I was performing best. And so then I had to like add more interesting, try to think more of interesting evaluation data sets that would sort of try to shape it in a different direction. So it was like, okay, the visualization is what is the most interesting bit about this. And when I presented it at an AI Tinkers talk last week, was it 2 weeks ago? That was the thing that was like, caught most people's attention. So that was this was very fun to build, or very fun to see it emerge and then use it as a feedback loop for further iteration.
Are there any libraries that help you implement the algorithm itself, like from GEPA or GEPA?
GEPA is mostly implemented in Python, and there are equivalents in TypeScript, but they are quite large and built as frameworks. And so I decided to do a classic thing of just, just roll.
And maybe they've well, okay, so we should shout out the so there's DSPy, 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 whatever you want to call it, in Python, and the type set of utilities for not only prompt, it's like declarative prompt engineering, but also prompt optimization. It's a big framework. It's a whole kind of approach to doing prompting that is a little different than just writing text. But they have a GEPA implementation. I think some of the DSPy very large contributors, if not the authors, were involved in the GEPA paper.
Yeah.
So they very quickly, after the paper was released, implemented GEPA in DSPy. As for TypeScript land, I tried doing GEPA with, so there's a DSPy, it's the unofficial DSPy of TypeScript. It's called AX, which I think is supposed to be for agent experience, probably, or AXLLM, AXLLM. And their GEPA, and this was like a month ago, so it may have changed, but it did not have support for a seed prompt, which was kind of critical for me. Like you had to use, I don't know, it just didn't, and I was trying to adapt it for, MCP server tool descriptions, which is not how they think. Like that library doesn't think in terms of like, oh, you want to modify a tool description across multiple. So like for the MCP use case, we also kind of need access to the algorithm in the sense of like, we need to control what happens to generate candidates, because we're like, if you think about, this is another interesting part of this, I think, was if you think about when you control the agent loop and you're optimizing the prompt, then yes, on each iteration, you can just go into the code and change the prompt and rerun the prompt against some stuff. And I feel it's a little bit different with like MCP server. Oh, no, I guess it's not. If you mock the tools, it's not quite. But it's a little different with MCP server descriptions, especially if you were evaluating against multi-step flows and things like that. Then you actually need to create like a shadow copy of your MCP server in some capacity. Or spin it like, you're left with like, oh, do I just spin up an entirely new MCP server with modified code? Like, do I, what I mean? Like git work tree, like 10 different MCP servers that I can then swap out the descriptions, or do I use some sort of gateway where I can change the descriptions on the fly, which I think is what you did, Lau.
Yeah.
Those are kind of like were interesting sub problems to like, okay, yes, it's cool to have this idea of multiple candidates for MCP tool descriptions, but then when you get into the nitty gritty of actually using those in an evaluation, how do you have like lightweight environments with several different MCP servers running?
Yeah. In this case, this was essentially once the tools were loaded, they would sort of the execution callbacks would be removed, so we wouldn't actually trigger the MCP server. But the test was essentially, does the model output the right tokens for the tool to be called? And then you'd sort of hot swap the tool descriptions.
Is your demo code somewhere open source if someone wants to find it, or?
Yes, it's on GitHub fireplane/darlings. Let me see if I can pull it up. It's all very demo code.
I think that's okay if people want to understand.
It's been used.
If you want to see the different, like, I mean, Lau is also at a higher skill level than I was at 10 years ago. But just like, to me, a very funny thing is like, whenever you consider whether AI assisted programming has offered any lift, it's like Lau accomplished Darlings in a weekend, and I think it took me like most of a Saturday to do the colors app. And
I think we link both here in the comments of the YouTube video, so people can see
so
both.
Yes, there is a skill differential. I will concede that, and the passage of time. But for someone, this is the difference: writing everything by hand out of a textbook versus using a wizard, a very dumb wizard that.
I'm sometimes a much smarter wizard than I am, but someone someone who can build tools on the fly to help you also investigate its own thing and create these things. Like it's definitely like not something I would have had the time or energy to completely write my own.
Yeah, can't help but notice that you didn't star the repo.
Oh, hold on. I need to rectify that.
Please, everyone who's watching, please go and star the colors and stuff repo.
Well, okay, I gotta be honest, then we can cut the stream. But like the thing that made me concerned is that I know this used to have like 10 stars, and I haven't looked at it in a while. And then all of a sudden I open it and there's 4 stars, and I'm like, oh no, what did I do?
Oh.
Someone went intentionally unstarred the repo. I don't think I've ever done that, to be honest.
I don't know, man. Did someone unstart? Maybe they deleted their account. Maybe it was a bot.
But that's why you brought it to the stream, to get the 10 stars again. Now I know.
I need more stars on that repo than I have subscribers on my dramatic readings of source code YouTube channel. So that's my goal.
Okay, so maybe after, like, we will check in the status of your stars next week. So we can see it. Also, because it was interesting and I'm not multitasking, I tried to look up the About page from GEPA, the chocolate company. I couldn't find really what it stands for. Maybe it's way hidden somewhere, but I couldn't. So I don't have an explanation here. We just know it's chocolate or the algorithm now. So.
Oh, all right. This was a kind of a. This was a different stream.
It is.
Yeah.
Next time, dramatic reading of papers.
I'm going to.
Buckle up, everybody. Get your calendar.